Welcome back, mathematicians. This time we're going to be talking about logarithms, or commonly known as logs. This is our common form, right? We call this log base b of y. Again, we have parentheses, so we're going to say of is equal to x. And how we can convert this form into a form we kind of know. Again, base b to the x power. So base b to the x power is equal to y. Okay, so you see how our base is still a base, and then we're going to put it to the x power, and we're going to set that equal to y. So these two things are equivalent, right? If or only if. Next, we have a common log. Common logs are just one of those things that's a notation thing. If you don't see a symbol down here, you're going to assume that it's 10. Not that it doesn't have any base. This still has a base. It's a base of 10. So this is pretty common, and that's why it's called a common log. And lastly, we have a natural log. We're going to hear more about this later. When we start talking about solving and converting. But basically, if we have a log base e, and we talked about that special number e before, but if you have log base e, then we're going to say that is equal to natural log of x. Okay? So let's take a look at an example. We have this one right here. We're just going to convert that guy. And we're just converting forms, right? So I have log base b, log base 3 of 9 is equal to 2. Well, let's see if we can convert it. Well, if I look at my other example, if you have to pause it and go back and look at that example, but I'm going to take my base 3, put it to the second power, and is equal to 9. And so sometimes we'll say, is this thing true? And in this case, it is, right? 3 to the second power is equal to 9. That checks out. Let's go ahead and take a look at our second example. So I have log base 5 of 0.2 is equal to x. So what I'm going to do is convert that first, right? So I have 5 to the x power is equal to 0.2, right? Again, this is the same conversion that we're doing this before. So this 9 goes to the other side of the equals. The 2 goes to the power of our base. In this case, we have a 5 as a base, and we have the power of x is equal to 0.2. Well, this side on the left-hand side doesn't look like I can do anything with that one, so I'm just going to rewrite it. This one I'm going to convert to a fraction. So it's 1 over 5. And if we don't know how to do that, we can plug it into our calculators, and it'll do it for us. Otherwise, it's go ahead and ask me later, but it's something that we should be able to do. So now I have something that looks kind of familiar, right? So let's take a look at this side again. This is 5x is equal to, I'm going to actually convert this, right? So this 5 here, we're going to take it and we're going to change the form of it a little bit. So I know that I can bring it up if I change the sign of my exponent. So I'm going to say 5 to the negative 1 power. Well, now look at what we have. I have a base of 5 here and a base of 5 here. And I have an x here and negative 1 here. So we should conclude that x is equal to negative 1. And if you test it out, it should be true. All right, now it's your turn. You're going to try and solve this guy. So I have log base 125 of 5 is equal to x, right? So again, that's log base 125 of 5 is equal to x. So solve for x. And I'll catch you on the next video.